Good day everyone, I am Alima Alim. I will discuss some topics or problems under abstract algebra. This is to be passed by Sir Joel C. Patinis Jr.
Good day and Assalamualaikum warahmatullahi ta'ala wabarakatuh. For now, I am going to discuss some problem in mathematical induction. But before that, I am going to define first what is mathematical induction. Mathematical induction is a method of mathematical proving typically used to establish that a given statement is true for all natural numbers or the non-negative integers. The simplest and most common form of mathematical induction proves that a statement involving a natural number n holds for all values of n. Okay, we have here a problem that we are going to prove using mathematical induction. 4 to the power of n minus 1 is greater than n squared for n is greater than or equal to 3.
Prove 4 to the power of n minus 1 is greater than n squared for n is greater than or equal to 3 by mathematical induction. First step we need to do is to show it is true for n is equal to 3. Okay, let us go first with the LHS or the left hand side. That is the 4 to the power of n minus 1 as what I had mentioned. We have to substitute n into 3, so it will be 4 to the power of 3 minus 1. So let us subtract first the exponent which is 3 minus 1. It will become 2. It is now 4 to the power of 2. And then 4 to the power of 2 is equal to 16. Our left hand side is equal to 16 now. Now, let us proceed to RHS or the right hand side, which is n to the power of 2. Again, substitute n into 3. It will be 3 to the power of 2. And then, 3 times 3 is equal to 9. Now, left hand side is greater than right hand side. Therefore, it is true for n is equal to 3. Now, for the step 2 is we are going to assume that it is true for n is equals to k. That is 4 to the power of ka minus 1 is greater than k squared. We substitute n into k. That's why we have 4 to the power of k minus 1 is greater than k squared. Now, for the step 3, let us show if it is true for n is equals to k plus 1. That is 4k is greater than, open and close parentheses, k plus 1 to the power of 2. So 4k is our left hand side because if we substitute n into k plus 1, it will be 4 to the power of k plus 1 minus 1. So positive 1 minus negative 1 is cancelled. That's why it is equal to 4 to the power of k. Now 4 to the power of k minus 1 plus 1. Then now multiply both LHS or the left hand side and right hand side into 4. The result will be k to the power of 2 plus 2k to the power of 2 plus k to the power of 2 is greater than k to the power of 2 plus 2k plus 1. By the assumption, 4 to the power of k minus 1 is greater than k to the power of 2. 2k to the power of 2 is greater than 2k and k to the power of 2 is greater than 1. For k is greater than or equal to 3. The right hand side now is equal to, open and close parentheses, k plus 1 to the power of 2. Now, left hand side is greater than right hand side. Therefore, it is true for n is equal to k plus 1, assuming that it is true for n is equals to k. Therefore, 4 to the power of n minus 1 is greater than n to the power of 2 is true for n is greater than or equal to 3.
So that's the end of my video. Hope you learned what I had discussed. That's all.